Hello everyone, welcome to Physics 2212 Lab 3 Magnetic Field of a Bar Magnet. The purpose of the lab is we're fundamentally exploring the Biot-Savart law. I might be saying that wrong, forgive me, but basically what we're trying to do is manipulate observation distances, or observation locations if you will, of our phone and a bar magnet and along various axes to see how that impacts the value of the magnetic field. And we will do that by determining the direction of true magnetic north. So we're going to do that by downloading some sort of magnetometer app. And you're going to lay that on a table, and you can adjust that until your phone's pointing at true north, and you'll know that by the x component being 0. You can then set up a ruler on the east-west direction, which is also obviously 90 degrees to your phone when it's pointing north. You can use tape on your phone to dictate the north, south, and east, west directions exactly where those are at, and that intersection will reveal to you where the sensor is, which that's going to be more down the line. And you can record data at various points and at a 45-degree angle to the ruler, and that 45-degree part will come in later. But regardless, you want to make sure you're recording data at various distances and various magnetic fields. So as far as primary calculations, we're going to use this equation Kr to the n. So this might look like an unfamiliar equation, and the reason for that is we are essentially using the general idea of a magnetic field equation, which is given as mu naught over 4 pi times 2 mu over r cubed. And what I mean by that is k is just all those constants shoved into one equation, or shoved into one variable, and r to the power of n, well, r to the n represents to what power is r multiplied by to be proportional to the magnetic field. And of course, we can rearrange this equation, and this looks just like the good old y equals b plus mx. I exchanged the usually mx plus b, but just for sake of argument. So anyways, by rewriting that equation in this fashion, we are able to solve for what n should be. And of course, we know n to be r cubed, right? Because magnetic field is inversely proportional to the cube of r. So we can use our data within an equation like this and solve it for a graph. So for my data, I was able to find n to be equal to negative 2.97, which is pretty close to the negative 3 expected value. Again, that value is negative 3 because you have to remember r would be in the denominator. But then we have this extra part, right? This k value, this negative 14.382. So this represents the len of k right over here. So if we just plug that into the len of k, and then we recall, okay, what did we establish k to be equal to? Well, we established k to be equal to mu over 4 pi, right? Which is equal to 1 times 10 to the negative 7th. Also 2, because it's on axis, and then times mu. So we're able to solve for mu from that. So our magnetic dipole moment from this equation is 2.84. Now we can also do, if you recall earlier, I said keep in mind at the 45-degree angle. Well, this is that part here. So using 45 degrees to the sensor, we're able to plug in data, as you can see on the bottom of your screen, and solve for an average value of what our B net is. So this is pretty self-explanatory. You can kind of see how it's described within the rubric or the procedure. But we can also compare that calculated data for this B net, again just using the standard Biot-Savart equations, with our glow script model. So basically for the glow script model, the premise is you really just use the given glow script code in addition to plugging in what your K value was, and you also want to plug in your average distance, dperp here. And you're given this, right? And there's just a few notes I want to make about it. For the on-axis arrows, you can see that they're pointing in the same direction as the magnetic dipole moment. And you can also note that they are double in magnitude to the perpendicular arrows. Notice how they point in the opposite direction and have exactly half the magnitude. Just some reflection questions for you real quick. If you didn't exactly put your phone to magnetic north, the data would be skewed and slightly less accurate. Actually, not slightly, pretty significantly less accurate, depending on the severity of your angle. And if you ran this experiment again with two connecting magnets, well, I mean, if you think about it, it really wouldn't change all that much. Recall we placed a magnet at the bottom of our ruler. And if we had two magnets all pointing in the same direction, that'd essentially be one magnet double the magnitude. So our magnitude of the magnetic field would be double, but all other data would remain about the same given the direction of the magnetic field is the same. All right, thank you all for watching.